This is Mr. Baker, and now we're taking a look at the radicals and imaginaries worksheet. This is our 4th out of 5 review worksheets for the integrated 2 and the course test. Don't forget to look at some of these things you've got in this title slide. It's got some formulas and just some reminders. All right, this first problem is really 2 problems. Looks a lot like our mini quizzes we had over complex numbers, just doing some operations with them. The first one is a subtraction problem, and that's super important because way too many people get carried away and try to multiply these out. Same thing with just polynomials. Watch for that sign right there. If there's a sign in between the 2 sets of parentheses, make sure that's what you're doing. Now to subtract, we've got to distribute the negative because subtraction is adding the opposite. So we're just going to, and then we can just combine like terms. What like terms do we have? We got 5 and -7. In the I department, we also have a -i and a -4i. Those are like terms. 5 plus -7 is -2. -i plus -4i is -5i. That's going to make our answer B. Now, let me call attention to this real quickly. We've got a non-calculator problem, no calculator here. I fully expect these problems to show up in the non-calculator part of the test. That's subpart 1 of the end of course test. There certainly are calculators that can handle working with I. We didn't talk about it because I don't really expect that to come up at all on the end of course test. Any problem that's going to be like this is probably going to be on the non-calculator part. Now this second half of this problem does ask us to multiply. Same 2 sets of parentheses, same 2 complex numbers, but we're going to multiply them out. That's a double distributing problem. FOIL, some people like to call it. I like to call it double distributing. So let's distribute the 5, and then we'll distribute that -i. Make sure the negative goes with it. So it's going to give us 5 times 7 and 5 times 4i and -i times 7 and -i times 4i. So that's 5 times 7 is 35, then plus 20i. That's a negative, so it's going to be a -7i. And then -i times 4i is going to be -4i squared. Make sure that I times I comes out I squared. And that's the big important part of this problem. That's what makes the I different from the X problems. Because I squared, we're not allowed to have I squared in an answer. I squared is always equal to -1. That's one of those big important things about I. So that I squared turns into a -1. So now I've got -4 times -1. That's going to be a +4. So 35 plus 20i minus 7i plus 4. Now I can combine like terms. 35 and the 4 are now like terms. That's 39. And then 20i minus 7i is going to be a +13i. So 39 plus 13i, my answer here is J. Just watch out for that. The 2 big things that catch people. Don't multiply when you're supposed to subtract. Pay attention to your signs. And when you do multiply, make sure that where you get that I squared, the I times I squared turns into a -1. Problem 2 is just a little bit different. It asks us to look at a list of steps and pick which of those steps are the way to tackle this problem. Probably the best way to actually figure that out is to start doing the steps on our own. Don't sit and read all of those steps first and try to use them all. That would work too. Try following those steps and see which one works, but that gets a little confusing. So let's just try to solve and get this X by itself in this radical equation. Now, we didn't do a whole lot of working with radical equations this year. We've used square roots to solve things. We've done other things where we have to solve for X. And the technique is pretty much the same, whether it's an exponent or parentheses with an exponent or absolute values or sine or cosine. Getting X by itself is pretty much the same process on these. When there's something weird going on, you want to get the weird part by itself. So get rid of anything going on outside of that weird part. then get rid of the weird part, and then get x by itself with what's left. So it doesn't sound very scientific, but that's really what we want to do. The weird part here is definitely the square root, so let's do that. Let's start by getting that square root by itself. And the only thing going on the same side of the equal sign with that square root is that 3. So we've got to get rid of that 3. How do I get rid of the 3? That's 3 times the square root. I undo multiplication by dividing, so we divide both sides by 3. Now, if you look at the multiple choice answers, you'll notice 2 of them start by dividing both sides by 3. The other 2 start doing something wrong, so A and D are both out. So we've got a good start. We've got it down to 50-50 on the multiple choice part. But we're not done yet, so let's keep going. When I divide both sides by 3, those 3's cancel out. That's going to give me the square root of 7 plus x equals 4. Well, now that square root is by itself on the left side. There's stuff inside it, but I don't care about stuff inside it. We'll deal with that at the end. I do need to get rid of that square root. So that's my next thing, get rid of the square root. How do we undo a square root? Well, you square both sides. That's how you cancel out a square root. Square root and square cancel each other out. So let's square both sides. Now when we do that, I've got my multiple choice problem answered, because the next step on B was take the square root of both sides. Well, we already had a square root. We didn't want to take another one. So we wanted to square both sides. So C is definitely my answer. But this is the type of problem that could pop up on part 3, where it gives you a multiple choice part first, and then it wants you to do more with it, like go ahead and solve for x. That might even ask you to do something else later. So the third subpart of the test, that's the last one we'll take, could certainly have problems like this with multiple parts. So we've got the first part answered. Let's finish this second part up. Actually do the squaring of both sides. You square a square root, that cancels out. I do have to go ahead and square the 4. 7 plus x equals 16. Now I just need to finish getting x by itself, which is step 3, by the way. And the multiple choice answer kind of gives away what we need to do. I got to get rid of that 7, so I'm adding that 7. I need to subtract 7 to make it go away. So that leaves us with x equals 9. Now, technically with a radical equation, especially a square root equation, you do want to plug that answer back in to make sure it really works. Sometimes you'll get an answer, but it won't actually solve the problem. That's called an extraneous solution. I think we've talked about it very, very briefly in class. In this problem, it's not a big deal. If we plug in that 9 into the original problem, it works great. It is always a safe thing to do, just in case they want to hit you with a no solution. But that's, if you've got time on the test, that's a good thing to do anyway, is to take your answers and plug them in for X, make sure they work. All right, number 3 should look pretty familiar right here. That is, Lucas has plugged into the quadratic formula from this quadratic equation. And it says he plugged it in and he's having trouble simplifying it. If you want to go ahead and verify and make sure he plugged everything in right, that's not a bad plan. But I think it just wants us to simplify it. This one doesn't say that it's a non-calculator problem, but it does seem like the type of thing that could show up on a non-calculator part of the test, because it wants it in simplest radical form, because that's how we almost always want these. So let's try it. Let's try simplifying this. The important thing is to know what to simplify. Even if you do use your calculator, don't shove the whole thing in the calculator. It's going to give you an error on this problem, or it would just give you a decimal. It doesn't like problems like this. But we can tackle it. There's really 3 things we can simplify all at once, whether it's by calculator or by hand. And I like to go ahead and get the squared part, that minus 4ac part, and that 2a part in the bottom. All 3 of those we can simplify. So that's going to give me 2 plus or minus the square root of Negative 2 squared is positive 4. Make sure you get that positive 4. When you square a negative, you get a positive. Negative 4 times 3 times 4 is 48, but it's negative 48 because that minus was already there. Be really careful with your signs on these problems. That's one of the things that gets you, especially if that C value were negative. Negative times a negative would come out positive. This one was just the 1 minus, maybe a little easier to keep track of. And of course, the 2 times 3 in the bottom was 6. Well, once I get this far, now I can simplify what's inside the square root. But I don't want to tackle the square root, actually square rooting anything yet. I want to have one number inside before I try to take the square root of it. So that's going to be 2 plus or minus the square root of negative 44 all over 6. Now, the square root of a negative, that should set off some alarm bells. What we need to do. How do we take the square root of a negative? Well, it's not as painful as it sounds. We pull an I out. So that part right there, it becomes an I, because you never leave a negative in a square root. That's where imaginary numbers come from. Now, what about that 44? Square root of 44 doesn't come out nice. 49 would, but 44 doesn't, and we don't want a decimal. So we need to factor down our 44. What multiplies to be 44? That's 4 times 11. 4 is 2 times 2. When can I take something out of a square root? When I have a pair. And I have 2 2's right there. 2 2's inside will give me 1 2 on the outside. That 11 doesn't have a buddy, so it's stuck inside. So now we've got 2 plus or minus 2i square root of 11 all over 6. I've simplified that square root as much as it can, including pulling out the I. But I'm not quite done. I'm almost done, and there's different schools of thought on what to do next. There's some factoring techniques, but the way we've mostly talked about it is we're really simplifying a fraction, but the fraction has 3 things to look at instead of just a top and a bottom. We've got 2 things at the top to look at. The first number and the number we pulled out of the square root and the bottom number. If we look at all 3 of those things, we want to see what goes into all 3. Well, 2 goes into all of those, so we're going to divide all 3 of those things by 2 to see what's left. 2 divided by 2 is 1. That takes care of both the tops, and then 6 divided by 2 is 3. So that's going to give us 1 plus or minus I squared of 11 all over 3, and that's going to be my answer. Finally, we're done simplifying this, but I do have 2 boxes, not just 1. How do I put 1 answer in 2 boxes? Well, that's not 1 answer. That is 2 answers, because plus or minus gives us 1 plus answer and 1 minus answer, and that's what we write in the box, once with a plus and once with a minus. Number 4, lots and lots of words. And you get a lot of word problems that look like this, where really it's a lot of setup for one equation, and they give us that equation. V of t equals the square root of 25t over k. All of that fraction inside the square root. Almost everything else is telling us what these different things represent and what values we're going to need to plug in for those. So V of t equals 25t over k. What is any of that? Well, let's plug in what we know. We do know that we need to find k. It says, what is the value of k? So let's start with that. K is going to stay k in the bottom there. That's worth knowing. But we do know that t is the length of the tire marks. How long are the tire marks? 22 feet long are the tire marks. So that goes right there, 22. What else do we know? We know V of t is the speed of the vehicle, probably V for velocity. So if V of t is the speed of the vehicle, do we know how fast the vehicle was going? Well, it was 50 miles an hour. We can plug that in for v of t. Now, that's not v times t, that's v of t. That's like a y value. So we can just put that 50 there. Well, now we've plugged in for absolutely everything except for k. And they could have asked us for v of t. They could have asked us for t. There's all sorts of different ways they could have left something for us to find. But we've got it plugged in this way. Now we just need to get k by itself. So I'd probably start by doing that 25 times 22 on the top, because that just comes out to 550. Well, to get to the 550 or to the k, they're inside that square root. So once again, we've got a square root we need to get rid of. How do we get rid of a square root? We square both sides. The right side, the square and the square root cancel out. The left side, 50 squared, is going to be 2,500. So 550 over k equals 2,500. I don't like that k being in the bottom. I need to get it out of the bottom. One way to do that is to think of that 2,500 as over 1 and then cross multiply. When we do that, that's going to be 2,500k equals 550, because that's 1 times 550. And now one step left to get k by itself. I just need to divide. So let's divide both sides by that 2,500. That's what's there with the k. And that'll give me k equals 550 over 2,500. That'll simplify a fair amount. I can just eyeball it. 10 goes into it. 5 will still go into it after that. It's going to be 11 over 50 when it simplifies. So we could have divided the top and bottom by 50 or done it one little piece at a time. Or since this was a problem where a calculator is perfectly fine, which is where I would expect this to show up, you can always put 550 over 2,500 in your calculator as a fraction, and it'll simplify it for you. We shouldn't need that. We should be okay. But I get it. We got a lot going on in our heads during this test. Sometimes a little thing like that, it's good to have a calculator that can take care of that for you. Now, here's the last catch. This one's actually a multiple choice problem. I hid that from you because I'm sneaky like that. And none of these answers look like the answer I got. I got a fraction. These are all decimals. Well, again, that's back to the calculator. All we got to do is 11 divided by 50. It's probably the easiest part of the problem. And that's going to give me 0.22. Why didn't I make this a multiple choice problem on your worksheet? Mostly because I didn't want you to just plug the numbers in for k and see which one came out right. It would work, that would work great, but I don't know if it's going to be a multiple choice problem on the actual end of course test or not. I don't know if there's going to be a problem like this at all on the actual end of course test. So these were some steps that we definitely needed to go through. You will definitely have problems on the end of course test where they give you an equation and you've got to solve for some part of it. Whether it's multiple choice or a free response, I don't know. So this was a good example, and we can always go back and try plugging in that 22 for that k, make sure it comes out the way we expect it to. Both sides should equal 50. All right, number 5 is asking us to simplify some radicals. Now, I've noticed some people working in class trying to change these to fraction exponents, which is not a bad instinct, but that's not what the directions simplify means. That's usually what it's going to say. It might even say write in simplest radical form. But both of those mean we're going to keep the radical in there, just pull out whatever we can from the radical. The only reminder most people need on how to do this is just the start of a factor tree, because we've done a ton of this in class. So let's start with 99. What multiplies to be 99? I always think 9 and 11 first. 11's prime, so we can stop there. 9's not, that's 3 times 3. Well, we can start simplifying straight from the tree if we want to. A lot of the times I like to go ahead and put it in its own radical so we can pull things out. So let's put that 3, 3, and 11 inside the radical. They're being multiplied. Multiplication works very nicely with radicals. We're never adding these. It's always multiplying. But that's not all I've got inside that radical. I've also got some x's and y's. Specifically, I've got an x to the fourth. Well, that's 4 x's. I've got a y to the third. That's 3 y's. They all belong in there too. Now, when can I take something out of a radical? Well, I can take it out when I've got a pair of them. So what pairs do I have? I've got a pair of 3's, a pair of x's, another pair of x's, and a pair of y's. And I have to trade in those pairs. You have to trade in 2 3's inside to get that 1 3 on the outside. Same thing with the x's. 2 x's inside gives me an x outside. 2 more x's inside give me another x outside. And same with the y's. Anything that didn't have a buddy has to stay inside the radical. So that's the 11 and that last y. Everything outside gets multiplied together. Everything inside gets multiplied together. And it's going to give me 3x squared y times the square root of 11y. Now this second problem here is pretty close to being the same thing. That one difference is that 3 in the index. And that's telling me how many things I need in a set. Instead of a set of 2, like I did for a square root, I need sets of 3. But I'm still going to do my factoring down. I'm still going to throw stuff in a radical. Just make sure your radical has that index of 3 still all the way through the problem. Factoring down that 32, what multiplies to be 32? 2 and 16 is what I came up with. Maybe you went 4 and 8, but I went 2 and 16. 2 is prime, 16 is not. 16 is 4 times 4, and those 4s are each 2 times 2. So really that's just a whole bunch of 2's, 5 of them, to go with how many x's? Well, it's 7 x's. Now when I'm doing a cube root, like we were just saying, I need sets of 3. So what do I have sets of 3 of? I have 3 2's, I have 3 x's, and even 3 more x's. Trade in each of those sets of 3 to get just 1 on the outside. So outside I get a 2 and 2 x's. Inside we've got these 2 2's inside. We've also got that lonely x inside. They're going to go inside a cube root. And finally, we should be able to multiply that stuff, the outside together, multiply the inside together. We end up with 2x squared, cube root of 4x. Number 6, which of the 2 of the following are equivalent to j to the 3/4 power? This is where we really do have fraction exponents getting involved in the mix. And we've worked a lot with these. We had a whole set of mini quizzes over what to do with fraction exponents. We know that fraction exponents can turn into radicals. When we do that, the bottom of the exponent becomes the index. So that's going to give us the 4th root of j to the 3rd power. Now, the way I've got it written there looks a lot like C. I don't have any parentheses, but the exponent is outside, and that means exactly the same thing. Does the exponent have to be outside? Well, if j is the only thing inside, then it doesn't have to be. It could also go inside. Doesn't really matter if the exponent's inside or outside, again, because there's just the j inside. If there were more things, it would be more important for the exponent to go outside. But with just that one thing, yeah, certainly can go inside. We can even take a look at some of these wrong answers. B is definitely not the right thing. It's got the exponent and the index switched. D, it's got a cube root. Again, that index isn't supposed to be a 3, and they've got the 4 in the bottom, I guess trying to play off of the 4 in the bottom of the exponent, but we should know that's not right. And E's got a square root instead of a 4th root. No 4 to even be found. E should be an easy one to eliminate. But we can certainly see this kind of problem going this direction, the other direction where it starts with a radical, maybe even that difference between inside and outside exponents, giving us a correct answer. So we should be able to hop back and forth between fraction exponents and radicals easily enough. We'd certainly worked on it enough with our mini quizzes and other things in class. And number 7, Mariah has a trigonometry problem answer. It's got a fraction with some square roots in it. And the teacher says she's got the answer right, but it's not in the right form. The denominator is not rationalized. What does that mean? Well, to rationalize the denominator, we get the square root out of the bottom. We can't keep a square root in the bottom. That's just not the normal way that we write stuff, because we want all of our answers to look the same when they're in simplest form. Well, realistically, what that means is we're not actually going to get the square root out of the bottom. We're going to get the 7 in the bottom, get that out of its square root. And as we talked about earlier, and I've done a bunch of times in class, to get something out of a square root, we need 2 of them. But I've only got one 7 here, and it's prime. It's not going to factor down. But I can bring in another square root of 7, and now I have 2 7s inside a square root, as long as I'm multiplying them. So I can multiply the bottom by the square root of 7. But if I multiply the bottom by the square root of 7, we have to multiply the top by the square root of 7. Now in the bottom, 2 7s inside gives me 1 7 on the outside. So that's just a 7 outside to go with the 2 that's already there. On the top, I'm multiplying. Remember, when you're multiplying radicals, we can multiply outside numbers times outside numbers. Well, the only outside number is 3. I can also multiply inside numbers times inside numbers, and they go inside. So that's going to be 3 times the square root of 5 times 7, which is 35. On the bottom, 2 times 7 is 14. Can I simplify that? I need to think about it. I can't cancel something inside a radical with something outside a radical, but I could maybe pull something out of the radical. Well, not this time. Square root of 35 is just 5 times 7, no pairs there. And I could also simplify an outside number on the top with an outside number on the bottom, but nothing goes into both 3 and 14, so that means that that's our answer. Always think about simplifying your answer. Simplify the radical, simplify the fraction part. But if it can't be done, then what you've got is your answer. So that's all 7 of these, radical and imaginary. There's certainly lots of different ways we can ask these kinds of questions, or different problems they could ask. We're just trying to bring these things back to the surface of your brain. I hope some of it sounds familiar, and if some of it didn't, I hope this helped you wrap your head around it.